Um, if you didn't read your email, I'm going to explain that form here from yesterday's notes. So if you look at example B on the first page, this is your Math Excel is asking for that summary statement. This is your fraction form, the answer to the problem, including your fractional remainder. So this is your fraction form. Your polynomial form, which is the part that they're asking for, that you're like, what is that? So I'm going to abbreviate it as polyform. As I explained in that email, you take what you divided by, so what's outside of the division bar, which in this case is 3x plus 2, and you multiply it to the non-fraction part of your answer. So you get x squared plus x plus 2. But I have to make an adjustment, because technically I have to be able to take what's outside here and multiply it to the answer up here and get exactly what's underneath. Well, let me move this over here so you can see it. I went ahead and I multiplied out 3x plus 2 times x squared plus 2. And I put it on the board. I'm trying to get the white there so that video will pick it up. So if you look at this, so I multiplied, take that out for a minute. I multiplied these two together. So all I did was just double distribute, and I ended up adding like terms, and I got this. Is this exactly like what's underneath here? What's the one thing that's different? This 4 is not a 7, but what's the remainder? 3. So if I added 3 to this, wouldn't it now look exactly like that down there? So I also have to add 3 up there. And that's what becomes the polynomial form. And so, let me move that back. And so, on our notes, to finish off our polynomial form, we're going to have to add just the non-fraction form of that remainder, right there. Otherwise, if you just leave this with no remainder, you won't get exactly the same thing underneath. So we have to adjust for that remainder just by adding it after the product. Okay, so then look at part C. So this answer here that we got was our fraction form. So what's your polynomial form going to be? What's your polyform going to be? So take what you divided by, 2x squared plus x plus 1. Multiply it to the non-fraction portion of your answer. So you've got x squared minus x. But then you have to adjust for that remainder. Well, this is a weird remainder. It's actually a binomial. So we're going to add it. If your remainder were negative, you would subtract it. But I am going to add it in parentheses, x minus 2. I want you in that habit, because if for some reason it happened to be negative, you would put a negative in parentheses. Synthetic division. So how do we write those when we have the synthetic division answer? So look at example 2. So the answer here that we came up with, this is your fraction form. So our polynomial form, I'm going to have to squeeze in up here. So our poly form. What did I divide by? Not a 2, but a x minus 2. So I've got x minus 2 times my answer. I don't include my remainder. Well, fortunately for us, our remainder here was 0. So our answer is 6x squared minus 7x plus 2. Because our remainder is 0, we're not going to put a plus 0 in there. So your polynomial form does not have a remainder added or subtracted from it. This one. This is the last one that we did, so this is our fraction form. Good? Okay. So this one is a little long for the polynomial form. So our poly form, what do we divide by for this one? your x plus 3 comes first, times our answer, the non-fraction portion of our answer, x cubed minus 13x squared plus 39x minus 118. But then you have to adjust for your remainder, so our remainder was 361. Since it's positive, we are adding the remainder of 361 to the end. So now you ought to be able to figure out and finish the rest of that. Any other questions on that? Okay. So then let's look at the other half of these notes. So the remainder theorem really is another useful tool for synthetic division. And here's what it says, and I'm going to explain better with an example than looking at what they're saying here. If you take a function and you divide it by a binomial, so we use synthetic division to divide it by a binomial, the remainder of that synthetic division is actually the answer if we evaluated the function for what we put on our shelf, in this case k. What does that mean? Well, look at this last problem here. If I wanted to evaluate this polynomial for -3, because that's what we put on our shelf, it would be written like this. F of -3 is equal to, wherever I had an x, I would replace that x with a -3. So I would have something to the fourth minus 10 times something cubed minus 2 times something plus 4. So I would put in here -3, -3, -3. How fun would it be to cube -3? I'm sorry, how fun would it be to take -3 to the fourth power? Well, 3 times -3 is 9. And you have another set, 9 times 9 would be 81. But then you have to cube this, which is -27 times -10, which is positive 27. Add that to your 81. Then this is a positive 6 and a positive 4, which is 10. Add that to that. Could you make a mistake while doing that? You can get to be some big numbers and possibly some sign numbers, right? Well, what this remainder theorem is saying instead, if you use synthetic division, this remainder here is the answer to that evaluation. The math here in synthetic division tends to be easier than the math in the evaluator. And I will prove to you on my calculator that if because I don't want to do it by hand and take up the time. So if I threw this in the calculator, which you wouldn't necessarily have used the calculator, minus 10 times -3 to the third, minus 2 times -3, and then plus 4. What was my result? 361. So I'm going to prove the usefulness of the theorem down here with this example. So we're going to do this one both ways. So if I wanted to evaluate the function at x equals -2, that means I'm going to replace f of x with -2. So everywhere there's an x, I'm going to use substitution parentheses. And replace each of those parentheses or place in there a -2. Now if I were to do this by hand, we have to raise every base to its exponent first. So I'd have 3 times -2 cubed is -8, plus 8 times -2 squared is positive 4. Then I can actually multiply this out, -10 and then -7. Then I have to multiply the 3 and the -8, which is -24. 8 times 4 is 32, minus 10, minus 7. Then I get to start with the addition. These two give me a positive 8, minus the 10, minus the 7. These two give me a -2 minus 7, which finally gives me a -9. Could there be cause for error there? Sure. So, or what the theorem says, instead of doing that, let's use the remainder theorem. So use the remainder theorem. It saves you quite a bit on work. So start with a polynomial. Is it written in descending order? Yes. Is it missing any terms? No. So then just write the coefficients, because we're going to use synthetic division. 3, 8, 5, and -7. Draw your L, vertical line in your shelf. So if I'm evaluating for -2, that is not a binomial, not a factor, so I don't use the opposite sign. I put -2 on the shelf, and I'm going to put whatever I'm evaluating it with exactly as is on that shelf because it's not written as a binomial factor. So then bring down your first term and start to multiply. -2 times 3 is -6. Add down, we get 2. -2 times 2 is -4. Add down is 1. Has the math been terribly difficult? Nope. -2 times 1 is -2. Add down. Don't I get -9? So isn't f of -2 equal to -9? Which one would you prefer to use? The left side or the right side? I prefer to use synthetic division. Typically the math is easier. So my point is, if you want to evaluate a function for something, and use synthetic division. It's quicker, especially if you don't have that calculator. All right, so I'll flip to the next page. Yes. Mm-hmm. I will not test you on polynomial form because I find it useless. But you need to know it so that you can answer math Excel questions too. I don't really find it useful in calculus. It's next question too, so it's useful if you wanted to check to see, but I just don't find it useful. Okay, so let's look at the factor theorem. We've already talked about the factor theorem, you just didn't realize it. And here's what it's saying, kind of in a nutshell. It says f of x has a factor, it's a binomial, if and only if, when you evaluate that function for whatever this opposite number is in here, you get a 0. So I'm either looking for a 0 remainder in synthetic division, or if you were to plug in the opposite sign of this number here, and you got 0 as the value of your function, you know it's a 0, or it's a factor. That's all that that's saying. So we're going to show in example 4 that x minus 2 and x plus 3 are factors of a polynomial. Emphasis on the word show. That means they're saying that's a factor, so what do you expect the remainder to end up being? 0. So step 1, start with either one, it doesn't matter. But evaluate your polynomial. Is it written in descending order? Yes. Is it missing any factors? No. So write down your numbers. 2, 7, -4, -27, -18. There's a lot. Here's your L and your shelf. So if I'm going to start with x minus 2, what do I put on the shelf? +2, the opposite sign, right? That is written as a binomial factor. So then bring down the first number and start your multiplying. So 2 times 2 is 4. Add down, we get 11. 2 times 11 is 22. Add down, I get 18. 2 times 18 is 36. Add down, I get 9. 2 times 9 is 18. Add down, glory, hallelujah. We have a 0. So what does that tell you? It's a factor, right? Then, when you test x plus 3, test it now with these numbers, because notice that the rest of the question says, then find the remaining factors. I mean, you could test x plus 3 using the original numbers, and you should still get a 0, but the problem is, if you're finding the remaining factors, you have to keep using synthetic division, like repetitive division, over and over again until you pare it down to a quadratic. So we're going to start with this, with the x plus 3. So my step 2, I will be using the 2, the 11, the 18, and the 9. Otherwise, you're not going to pare it down to quadratic, and you won't be able to find the other factors. Now, could you have started with the x plus 3? Yes. These numbers are going to be different in step 2, but by step 3, you and I will have the same numbers to factor then. So put in your L, And then this time we're putting in x plus 3 down here. Where I put a negative 3. And bring down your first number. Use a 2. So start your multiplication. Negative 3 times 2 is negative 6. Add down. You get a positive 5. Negative 3 times 5 is negative 15. Add down, you get a positive 3. Negative 3 times 3, yay, is negative 9. Add down, and we do get 0, so it's a factor. Very happy. Haven't I pared it down to a quadratic? Because I went from x to the 4th, this is now 2x cubed, and isn't this 2x squared? And that's 5x. So in step 3, now you're going to factor 2x squared plus 5x plus 3, and I always like to set it equal to 0, just because when you have to go find irrational or imaginary factors, you'll need to remember to set it equal to 0. Remember, I'm finding factors, not zeros, so I'm probably not going to set the factors equal to 0 and solve it. If you don't know how to solve this, or factor it using factor sum of group and garbage, you better use the quadratic formula. But what the quadratic formula is going to give you is the zeros. You then have to convert the zeros to a linear factor, meaning it's binomial. So be aware of that. Take your bookends, 2 times 3, which is a positive factor of 6. So that means we are adding the factors of 6 and looking for a middle term of positive 5. What factors of 6 add to give you 5? What is it? 3 and 2. So they do add to give you 5. My 5 is positive, so the bigger of the 2 carries that sign. What does the 2 have to be? Positive also. So now I'm going to replace that 5x with the 2 new middle terms. So I got 2x squared, but I got a plus 2x, a plus 3x, and my bookend plus 3 equals 0. Cut it in half. What's the GCF for the first group? So 2x in front of parentheses, divide each of those by 2x. What do you have left? X plus 1. What are you going to factor out of the second group? 3. Make sure you put a plus 3 and not just a 3 there. And then divide each of these by 3. Do you get the same thing? You do. Because these are the same in parentheses, you're going to take that out in front of parentheses, and then you're going to take them away from there. What you have left over, the 2x and the 3 in front, they get thrown in the empty. Whoops, they get thrown away. So at this point, you could solve and find your zeros, but it didn't ask for zeros, it just asked for factors. So step 4, your factors plural. This is 1, which is your x minus 2. This is the second one, which is your x plus 3. And then these are your last two, because this is a polynomial to what degree? To the 4th degree. So how many factors should I have? 4 factors. And so these give me my other 2 factors. So there's all 4 of my factors. They might also ask you for zeros. They didn't here, but if they did, what's the 0 for this one? 2. And for this one, negative 3. And for this one, negative 1. What about that one? Subtract 3. So you get negative 3 and divide by 2. So you get negative 3 halves. Those zeros are rational and real, which means that they cross the x-axis. So in addition to being zeros, they are also considered x-intercepts. Not all zeros are x-intercepts. If they are imaginary numbers, they will not be an x-intercept. So you can have a 0 that's not an x-intercept. And we'll get to that if we get to 2-5 today. So questions on that? Okay. Now, if I don't give you the factors like I did on this one, and I just say to you, like in example number 5, find all the possible zeros and linear factors. There you go. Thrown you to the wolves. How do you know where to start? and there's a vast array, and you don't have a use of your calculator, it's a vast array of numbers you can choose. So the rational zero test helps you narrow down the field of real numbers, which is any number you can think of, in order to figure out which factors might be. And here's what it says. You are to take P and divide it by Q. Well, what the heck is P and Q? Here it is explained for you. P are the factors of the coefficient of the last term, and Q are the factors of the coefficient of the first term. So make sure, number one, that your polynomial is in descending order before you figure out what P and Q are. And so it's backwards alphabetically. P goes to the end term, and Q goes to the first term. So that's your P and that's your Q. Now your constant, you don't think of as a coefficient. Typically, your constant is your P at your last term. So that counts. So then for step one, to find all of my factors, I'm going to take P and divide it by Q, all of the factors of P, and divide it by all the factors of Q. That'll be my starting place. There's only two factors for 3, 1 and 3. But your factors can be both positive or negative. So I've got to put in a plus or minus 1 and a plus or minus 3. Then divide that by all the possible factors of 2. Again, there's only 2 for 2. Plus or minus 1 and plus or minus 2. Then you have to physically perform that division and simplify. So you're going to take every item in the numerator and divide it by every item in the denominator. So I'm going to start with 1 in the numerator and put it over 1. So what's 1 over 1? It's a tough one. Plus or minus 1, right? That's its reduced form. Then you're going to put 1 over 2. That doesn't reduce. So you get plus or minus 1/2. So now we're done with the 1. We put it over each of these two. Then go to your 3. So now start all over again. 3 over 1 is what? So plus or minus 3. And 3 over 2 does not reduce. So you get plus or minus 3/2. So these are all of my possible factors, rational factors. So these are possible, rational factors. That doesn't mean they're zeros. That's where I focus my attention at. So I now know I'm not going to choose 20. It's not in there. Here. Here's your last term. Here's your first term. It just is. You divide 3 by 2. You have to know how to factor 3. The only things that dividing for 3 are 1 and 3, and 2, 1 and 2. Then all I did was I took 1 and I put it over 1. That reduced to 1. I took 1 and I put it over 2. It doesn't reduce, so it becomes 1/2. So now I'm done with 1. So then you go to 3. Put 3 over 1, it reduces to 3. And put 3 over 2, it doesn't reduce, it's 3/2. So you take every item in the numerator and put it over every item in the denominator and reduce. You'll see as we get to more and more factors, as we go along, that they will start to repeat themselves and you don't write it down twice. But this one, we didn't have that many factors to choose. Now, what do you think my favorite factor is going to be? 1. I love 1. So I will typically choose 1. Doesn't mean it's always a factor, but I'm going to typically choose 1 because it's easy to multiply and all that kind of stuff. So I'm going to take my coefficients, 2, 3, -8, and 3. This is supposed to help you with this frustrating guess and check method using synthetic division. So if I'm going to check 1, I'm going to put 1 on my shelf. Bring down that first term, in this case 2, and go through the process. What am I looking for if this is a factor? A 0 remainder. So 1 times 2 is 2, add down, I get 5. 1 times 5 is 5, add down, I get -3. Oh, glory be, 1 times -3 is -3, and why am I so super happy? First shot out of the gate, we win. It won't always happen. Just count yourself lucky. So what I've done, I've gone from a cubic to a quadratic. I'm done with synthetic division because all I need to do is get this down to a quadratic. So this is 2x squared plus 5x minus 3. So I lucked out on the first try. You will never get me to try the fractions first. they're just no fun to multiply. So if 1 and then I would have tried -1 after that if it didn't work, and if that didn't work, I would have gone to 3 and then -3. If neither one of those works, then I would have thrown up my hands and started with a fraction. So I did get down to a quadratic, so step 3 is now my quadratic. So I'm going to factor. You might want to write yourself a note. It's a factor. Down there. So now we're going to factor 2x squared plus 5x minus 3. And again, I've just been in the habit of setting it equal to 0. I'm not going to solve for the zeros yet. But again, we have to use group and garbage. So multiply your bookends. 2 times -3. But this time I have a negative product for 6. So I'm not adding the factors of 6 this time, I'm subtracting them. And I'm still looking for 5. Put factors of 6 subtracted to be 5. Not 2 and 3. What subtract? 6 and 1. So be really careful that you know whether you're adding or subtracting. So that 5 is positive. The bigger the 2 carries the sign. What does the 1 have to be? Negative, otherwise it's not going to make positive 5. So then I'm going to replace that middle term with the 2 new middle terms. 2x squared minus x plus 6x, and my last bookend, minus 3. Cut it in half. Yes. Nope. If you put the minus x second, just know that in your GCF you have to pull out a negative. Right? Usually you'll see me put in, if I have a negative and a positive, I'll put the positive second. So I don't have to do that. GCF here is an x. So divide each of those by x. What do I get? Divide, what do I get? 2x minus 1. What's my GCF in the second group? And put a plus 3 in there. So you're going to divide each of these by 3. Do I get the same thing? Yep. And so I have the same thing in parentheses, so factor that out in front of parentheses. And then take what's in front of those two parentheses and throw them in the empty parentheses next door. So haven't you found your other two factors? How many factors am I looking for altogether? 3, because the highest degree of the polynomial is third degree. So I can write out my factors, and they want my zeros also. So step 4 would be my factors. So my first factor was here with the 1. So how do I write that as a factor? Opposite sign, so x minus 1. And these ones are already written in linear factor form. So you've got 2x minus 1 and x plus 3. So there's your factors. Then your zeros, you have to set those equal to 0 and solve. So what would this one be? 1. What would this one be? Add 1 and divide by 2. So you get 1/2. What's this one? Negative 3. Are these zeros all x-intercepts? Are they all real numbers? Yes. So they are all x-intercepts as well. Well, as you'll see with the next problem, this can be an exercise in frustration if you don't choose the right zero first. Yes.
So for multiplication, you have to try to find the factors.
Yeah.
You have to do that same for
The P over Q. Yeah. The P over Q is going to help you narrow down your choices. So if they don't give you any linear factors to start with, if you have nothing, you have to use P over Q to narrow down your field of choices.
But
If they do, then you start with those, yeah. And you're like jumping up for joy, thank goodness they gave me a factor. Because otherwise, where do you start? Well, you start with P over Q. You'll see in this next one, because there's a whole lot more factors to 8 than there was to 3. So this one becomes, you have a whole lot more choices. Yeah.
So we would have factor according to
The way we're doing it. That's what, so this is a quartic. Yes. Yippee. So I'm going to give you, after we do this, I'm going to talk about upper and lower bounds, which will help us narrow down our P divided by the Q choices. So in this one, Q is your last term, Q is your first term. So for my first step, I'm going to do P divided by Q equals. Well, all the factors of P, there's several, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Did I miss any? Nope. All divided by all the factors of 2, plus or minus 1, plus or minus 2. You can't leave your possible factors looking like that. You have to divide them out. So I'm going to take every term in the numerator and put it over the terms in the denominator. So starting with 1. What's 1 divided by 1? So plus or minus 1 is an option. It always will. Then put 1 over 2. That doesn't reduce, so don't I get plus or minus 1/2? I'm not starting with that one. But then skip over to 2. But 2 over 1, what does that give you? 2 over 1. Just 2. So then put 2 over 2. What does that give you? 1. Didn't we already write that? So don't write it twice. Then go to 4. What's 4 over 1? So plus or minus 4. What's 4 over 2? And we already wrote that, so we're not going to write it twice. Go to 8. What's 8 over 1? Plus or minus 8. What's 8 over 2? 4. So we already wrote that, don't write it again. So these are our possible choices. I can guarantee you I'm not starting with 1/2. These are possible factors. That still leaves us quite a bit to choose from. So, second step. Am I missing any terms? Nope. Is it in descending order? Yes. So I'm going to start with 2, negative 7, negative 8, 14, and 8. Well, my favorite to start with is 1. So bring it down. And start to multiply. 1 times 2 is 2. Add down, I get negative 5. And you always start to know right away if it doesn't work. 1 times negative 5 is negative 5. Add down is negative 13. 1 times negative 13 is negative 13. Add down is 1. 1 times 1 is, turn it 1, and I get 9. Not a factor. I'm very sad. So 1's out. Well, let's try negative 1. Because that's another easy one to throw in there. So step 3, since this was not a 0, I cannot use this part right here. I have to start back up again with the original. So I've done 2, negative 7, negative 8, 14, and 8. I'm going to plug in negative 1. Bring down the first term. Multiply. Negative 1 times 2 is negative 2. Add down, I get negative 9. Negative 1 times negative 9 is 9. Add down, I get 1. 1 times negative 1 is negative 1. Add down, I get 13. And negative 1 times 13 is negative 13. And I get negative 5. Well, all that tells me is how the negative 1's out. How are you?
Good. Did I tell you about summer school?
No.
Pretty proud of in the summer.
And
All A's, 96% of every single semester.
who was your teacher?
Yeah. No, it was Gibson and
Oh, wow. You taught summer school?
I've done another school in
Good girl. Okay. I'm probably not going to choose 8 because it's kind of a big number. Not highly likely it's going to be that one, but it could. I'm not choosing 1/2. It could be 2. I'm going to shot in the dark. Just shot in the dark, I'm choosing 4. You see how frustrating this can be? Start again. 2, negative 7, negative 8, 14, and 8. Please, 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 let it be 4. So I'm throwing in 4. Bring down the 2. 2. 8, add down, I get 1. 4 times 1 is 4, add down, I get negative 4. 4 times negative 4 is negative 16, add down, I get negative 2. Oh, yippity skippity, why am I so happy? Boom. Yes. Happy days. I have something to the 4th power. I've now pared it down to 2x cubed, have I not? I still have one more 0 to find before I can use my quadratic. So I could try negative 4, probably not likely. I'm just going to shorten up your work for you only because I know what the other one is. We're going with negative 1/2. That would have been the last one I would have tried, by the way. So at this point, you go through negative 4, 8, negative 8, finally do the 2s. You do the negative 2s, and you give up, and you go, okay, fine, it's got to be 1/2. I'm just suggesting that when you get to your homework, if you reach that frustration point, throw it in your calculator and look at the graph and pare it down that way. But you're not going to have that opportunity on the test. So I'm going to show you in a minute how to find your upper and lower bounds to cut out even more of those possible factors. So we're going to start with 1/2. And I'm going to start from here because I did pare it down and got a 0. So I can now start with 2, 1, negative 4, negative 2. So we're going to throw in negative 1/2, bring down the 2. What is half of 2? 1, and it's a negative 1. Add down, we get 0, which is always nice. Negative 1/2 times 0 is 0. Add down, you get negative 4. What's half of negative 4? Negative 2 times negative, so you get a positive 2, which, oh, looky there. But I wouldn't have tried that. Negative 1/2 would have been the last one I would have tried. So there's a factor. Yes, another one. All right, so now I've pared it down to 2x squared minus 4. So I've run out of room officially, so I'm going to go up here, do number 5. So now I'm going to factor. And here's where getting in the habit of taking 2x squared minus 4 and setting it equal to 0 will make your factoring a little bit easier. I mean, you could factor out at 2, but then you won't know what to do with the x squared minus 2. So let's add 4. So we get 2x squared equals 4, and divide by 2, we get x squared equals 2. How do you solve? How do you solve? Square root. But how many factors total am I supposed to have? 4, and I have 2 here. So shouldn't I end up with 2 answers here? Don't forget you have to do plus or minus when you take the square root of both sides. So you end up with x equaling positive or negative square root 2. Now those are zeros, right? They're not written as factors. So because they want your all, that's supposed to be all, by the way. Let's do step 6 up here. List our factors. So the first factor I found was this one, and the second one was this one. So how do you write that as a factor? X, opposite sign, minus 4. Now this one, let's just do it down here. Opposite sign would be x plus 1/2, wouldn't it? You cannot have a fraction in that linear factor. How do I get rid of that fraction? Where'd you get 2 from? What's the denominator? Right? So find the least common denominator, multiply it through. Don't you get 2x plus 1? That's the factor. So if you have a fractional 0, you have to multiply by the least common denominator to get rid of that. So we end up with 2x plus 1. And then these ones, how am I going to write positive radical 2 as a factor? Yep, x minus radical 2, and then the other one's x plus radical 2. So there's your 4 factors. No multiplicity, so they all cross the x-axis, and aren't they all real numbers? Look at your zeros. What's the 0 for this one? 4. What's the 0 for this one? Subtract 1, divide by 2, you get negative 1/2. What's the 0 for this one? And that one is at positive negative square root 2. Well, square root 2s are irrational. Notice that's why they're not choices here, because those are for rational factor choices. but they're still real numbers. So you are going to have 4 x-intercepts. All right, so how are we going to narrow down this field so we don't have this frustration happen? We can look for something called upper and lower bounds. And there are rules for what we call upper and lower bounds. This is just a gift from the math gods above. If c is greater than 0 or versus less than 0, well, the question begs, what the heck is c? C is the number on the shelf. What you're dividing in synthetic division by. So if c is positive, greater than 0, positive number, then what you're looking for in the last row, so you look at the last row of your synthetic division here. Look at that, very last row. If in each number in the last row is either positive or 0, then c is an upper bound. So the only positive numbers I chose were 1 and 4. 1, were all of these numbers positive or 0 in this bottom row here? No. So 1 is not an upper bound. And that makes sense because didn't 4 end up being a 0? Well, since 4 was a 0, you don't see positives or zeros here either because it was an actual 0. It's not an upper bound. It is a 0. Probably if I had put in 8s, I would have seen in this bottom row all positives and zeros. And I would have known, oh, there's nothing to choose after 8, but 8 is my biggest number here, isn't it? So that wouldn't have helped me much here. So then what happens if the number on that shelf C is negative, less than 0? Then I'm going to look for the numbers in the last row to alternate positive and negatives. So look at the 2 negatives that we chose. One of them was a 0, one was not. What do you notice about this one? Positive, negative. Oh gosh, it didn't work there, did it? So negative 1 is not the lower bound. Probably the negative 1/2 would have been the lower bound, but it turns out to be the 0, doesn't it? So this is one of those odd questions where the upper and lower bound wouldn't have helped in this one because your zeros were so far out to the right and left. Is that pretty discussable? Okay. So let's apply it to example 7. It's our last example for this section. Okay, so sometimes it's useful. So let's try to find, and this question is asking just for the upper and lower bounds. It's not asking for the zeros. So be really careful. You pay attention to what they're asking for. So all I'm looking for are positive possible factors that give me positives and zeros in the bottom row, or negative things that I'm dividing through that are going to give me alternating positive numbers. So let's look at this one. My P is 15. My Q is the 1, because that's in descending order. Am I missing any terms? Yes. I'm missing a 0x squared and a 0x, correct? I have to count for that eventually. So let's do step 1. Let's find all of our possible factors. So I'm going to take P and divide it by Q. What are the possible factors of 15? 1, 3, 5, and 15. The possible factors of 1 are plus or minus 1. So if I divide each of those by 1, don't I get the numerator? So these are my possibilities. And these are my rational factors. My possible rational factors. There could be irrational ones. I'm trying to get x to the 4th down to a quadratic. But really on this one, I'm looking for upper and lower bounds. So let's just start choosing. My favorite number is always what? 1. So let's start with that. So I've got 1, negative 4. Don't forget your 2 zeros. And then your 15. So I'm going to plug in 1 to bring down the first number and start your multiplying. So 1 times 1 is 1. Add down, I get a negative 3. 1 times negative 3 is negative 3. Add down, I get negative 3. 1 times negative 3 is negative 3. Add down, negative 3. 1 times negative 3 is negative 3. Add down, I get 12. Okay, so 1 is not a 0. Is 1 in upper bounds? It's positive. Do I see in this last row all positives or zeros? Shoot. So that means there could be a bigger number there. So while I'm at it, I'm going to check -1 because I might as well check for lower bound. So I'll check -1. So I've got 1, -4, don't forget your zeros, and 15. So this time I'm throwing in -1. Bring down your first term. -1 times 1, -1. Add down, -5. -1 times -5 is +5. Add down is 5. -1 times 5 is -5. Add down, -5. -1 times -5 is 5. Add down is 20. So although I didn't find a 0, look what I did find. When C is negative, I'm looking for alternating positives and negatives. Is this alternating positives and negatives here? Yes. So what I have found is my lower bound. What that tells me is there's no rational factors below -1. So that means I've killed out -3, -5, and -15. I don't have to try those in synthetic division. Plus, I've already tried +1 and -1, so those are out. All that's left for me to try is +3, +5, and +15. How am I not going to choose 15 off the bat? What are you going to choose between 3 and 5? I'm going to choose 5. Hint, 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 wink. So I didn't get a 0 yet, so I still have to start off with my original. 1, -4, 0, 0, and then 15. So I'm going to try 5. Bring down the first term. So 5 times 1 is 5. Add down, I get 1. 5 times 1 is 5. Add down, I get 5. 5 times 5 is 25. Add down, I get 25. 5 times 25 is, pretty sure it's not working, 125, and I get 140. But, very exciting. What did I find? All positives. So I'm looking for all positives and zeros, all positives. So this is my upper bound. And so what that tells me at this point is that means 15's out. And all I have left that I haven't tried is 3. So hopefully 3 would give me a 0, which then gives me a cubic. And at that point, I'm not sure what I'm going to do because I've run out of rational factors. But that's not what they're looking for here. They're just looking for you to find your upper and lower bounds. But at least it helps you to narrow down the field. So yes, you can get frustrated on your homework. They don't spend hours on it, use your calculator. So let's look at